All right, we'll give this a minute for people to get logged in, to sign up, and I'll go through some notes and help you guys out with the homework. Alrighty. Okay, Mallory's here. Mallory, I think you might just be the only one that, tends to be the pattern. Okay, so we're going to start these notes here. Calculus, how to find the area under the curve using rectangles. Now, we actually did this way back at the beginning of the year. We're doing it again because it's going to directly relate to what we just did with the summations. And eventually we'll talk about how we can use this with integrals and antiderivatives. So I'm just going to start with an example. And I will probably have to use multiple whiteboards. But I'm going to try to draw this example out as neat as I can. This would be a lot easier if I had like a big whiteboard and I could project it. But we're going to do our best here. So let's say I had a function that was like y equals x squared plus 4. And I'm going to draw this a little off center here. So that function would be like 1, 2, 3, 4. It'd start over here, and it'd be a parabola. Say I wanted to find the area from, let's say, from 1 to 3. If I wanted to find the area underneath this curve bounded in this region. Well, if I wanted to find this like this region here, I'm not going to shade it in because then I can't erase it. It'd be kind of tough. But what I can do here is I could break this down into rectangles. I could make this like a 1 by 1 rectangle, and I could go through and start from this edge here, from the left edge, and go over 1, and I'd have a rectangle here. Then I could go up here, 1 rectangle, in here, and I could have these 2 rectangle areas, and I could add those up together and find that. Now that's called left bound because I started on the left edge of the function. I could go on the right edge too and say, okay, I could start here on the right side, okay, and go left 1. Okay, now I have a bigger rectangle. And then I could go through and go from the right edge and go left again one more time and have 2 rectangles. And I could take maybe the area of the blue rectangles, the right bound area, and the left bound area, which were the red rectangles, and say, okay, the area underneath the curve would have to be somewhere in between those 2 areas. And what I could potentially do is, well, not just do 2 rectangles, but I could split them up and make 4 rectangles, like split them in half, like make smaller rectangles that go through. All right. And so I can say, okay, well, if I use smaller rectangles, there'd be more of them, and there'll be less difference between the actual curve. So I hope that showed up well on the screen. If not, I'm going to try to do my best with the homework problems of drawing them out a little bit, at least the first one, because I can do that kind of neat. And then talk about how we're just going to do this math problem. Okay. So the first 2 homework problems, they work together. It wants you to find the area underneath the function f of x equals 9 minus x. And we're going to look at the range from 2 to 4. And we're going to use 6 rectangles. All right. So I'm going to try my best to draw this here. So big function here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I know it. If I plug in 0, it'd be 9. It's a negative x, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. It'd go something like that. Now, if we're going from 2 to 4, all right, here's 2. And then here's 4. There we go. And what we're going to do is break this up into 6 rectangles. So that means each one of these rectangles here, from the left edge over, has to be like 1/3 of a unit. Nope. Okay. Alrighty, so what we got to think here is we have 6 different rectangles, and if we're going from the left edge, this first left edge is when x equals 2, and its height, the height of it, is f of 2, like whatever 2 is in the function, and then we'll just keep going over. So I'm going to take out another whiteboard here. And say like, okay, I have 6 rectangles, and this is all, we're doing left edge first. So I have 6 rectangles here. 1, 2, 3, 4, 5, 6. Now each one of them is a base times height, which if we see the base, we could figure out the base of each one of these rectangles is 1/3. It's 1/3 because you think about it, if we were going over 2 spaces split up between 6 rectangles, 2 divided by 6 is 1/3. And the height, well, let's see, they're all going to start changing a little bit. This first height here is f of 2. And the next rectangle still is 1/3, but that would be f of, well, if we'd have to move over 1/3, that'd be f of 2 1/3. Which, okay, let's probably change that a little bit. 2 1/3, that would be 7/3. And then the next rectangle will be 1/3, and then f of 8/3. Then the next rectangle would be f of 9/3, or just 3. I wrote 2, but. And then the next rectangle has a base of 1/3. F of, okay, 9 10/3. Then the next rectangle is 1/3. Then f of, let's see, 11/3. So we have our list here of all these rectangles and how to find the area of each rectangle. Now what we need to do is to go through and figure these out. Now, what I'm going to do is f of 2. For f of 2, I'm going to take 2 and plug it into the function here. And then the next one, I'll take 7/3, plug it into that function. So remember the function is, I'll put it over here, f of x equals 9 minus x for the first problem on the homework. So this one would be 1/3 times, okay, 2 plugged in, that'd be 7. Next one, we got 1/3 times, if I plug 7/3 in, that would be, let's see, 9. This is what, I could just grab a calculator, which I'm gonna. Distance learning, my brain isn't working as well. If it's in the classroom, okay, 9 minus 7/3, math, enter, 20/3, yeah, because that was 27/3 minus, okay, 20/3. Well, guess what? The next one's going to be 1/3, 19/3. There's a pattern here. 1/3, and then let's be 18/3, which is just 6 because we plugged it in there. And then 1/3, let's see, 18, 15/3. Well, does that work out? No, 17/3. And then 1/3, 16/3. So if we go through every rectangle here, we can go through and, okay, this one would be 7/3. This one here would be 20/9. This one here would be 19/9. 6 divided by 3, that's just straight up 2. and then we'd have 17/9, and then 16/9. So our area, the left edge area, is adding all these up. So we're going to add those all up. I'm just going to type that in the calculator. 7/3 plus 20/9 plus 19/9 plus 2 plus 17/9 plus 16/9. And there's the answer for number 1, 12.333. It does say round all answers to the 4th decimal place, so please put 12.3333. Okay, so that's the left edge. Now I'm going to leave this information up here because it's going to be really useful. 12.333. Because if we want to do the right edge, what we're going to do on the right edge is to start at the end here and work our way over from the right, which we'll probably notice a couple things happening if we start on the right edge and move over. One thing that we'll notice is that all the widths are still the same. So we still have here right edge. We still have 6 rectangles. 1, 2, 3, 4, 5, 6. We're all doing base times height. So they're all 1/3 width. Why does your video keep pausing? Good question. You know what? Matt? Thank you for letting me know. I'm going to have to change my... Yeah, I'm on the 2.4 gig. So I'm going to end this video right now and then restart a new one so I can keep this. Thank you, Mallory. All right, end.